those. Okay, so I want to talk about types of equations. There are many, many types, but what I'm referring to right now here is identity, conditional, and contradiction. Okay, an identity has infinitely many solutions. Infinitely many solutions. If you see me, don't be shy. It doesn't upset me ever, ever. If you see that I swallow a letter or something, always tell me, because I try to write in uppercase so everyone understands what I'm writing. So that's why sometimes I skip a letter and I think of the next word. No excuse, no excuse. Okay. So here's an example of an identity. 2x plus 1 equals 2x plus 1. This equation will have infinitely many solutions. How come? If x is 0, 1 equals 1. If x is 1, 3 equals 3. If x equals 4, 9 equals 9. If x equals negative 1, negative 1 equals negative 1. And I can go on forever. This is an identity. The left-hand side is identical with the right-hand side. So this equation has infinitely many solutions. What is a conditional equation? A conditional equation is true for specific values of x. For example, let's say 2x equals 4, x equals 2. So it's conditional. It is a true statement only if x is 2. Is it true for x equals 3? No, it's not, because 6 does not equal 4. So when x is 2, this is true. For anything else, it's not. So this is called conditional. What about the contradiction? So here's an example of a contradiction. 2x plus 1 equals 2x minus 3. When I simplify 2x or subtract 2x from both sides, I get that y equals negative 3. False. So I did not get any x value. There is nothing that works here. And furthermore, I got a false statement. It's not only that I don't have x, but I got a false statement that is not acceptable. So we say that this is a contradiction. And this one has no solutions. This one has one solution. It may have 2 solutions. It may have 4 solutions. It may have 5 solutions. But the specific finite number of solutions. A specific number of solutions. Carved in stone. 1 or 2 or 3 or 10. So these are type of zero equations. Identity, infinitely many solutions, all of them work. Here, only specific ones work, maybe 1, maybe 2, maybe 10, but not infinite, finite, strict. And here, nothing works. Okay, 1 second so I can check if I can delete these. Yes, I can delete all the other ones. So I can make room here. Okay. Empty recycle bin. Yes. Okay, it's done. Perfect. So now we're going back and select problems. You select, I select, and so on and so forth. Good. We may recognize many of them. If we do, we move on. If we need to select, we select. A student tries to solve the equation. The student's work is shown to the right. So let's copy the equation. So 2x minus 7 equals x minus 8. Describe any errors, then solve the equation correctly. So the first step, 2 quantity x minus 7 equals x minus 8. Is the next step correct? 2x minus 14 equals x minus 8. Is that correct?
Yes.
Yes. Then he added 14 to both sides. So he added 14 here, and he added 14 here. The left-hand side was just 2x, and the right-hand side is 6, x plus 6. So 2x equals x plus 6. Do we agree with this next step? This is not what I would do, as you know my style already, but this is correct. It's 2x, and the 14 minus 8 is indeed 6. Good. Now, careful with the next step. Is the next step correct? At this point, to divide both sides by 2. Is this correct?
No.
No. What do we need to do first? Because we
combine like terms. So
meaning
you gotta move the x to the other.
Exactly. So then x equals 6. So that's where the problem is. You cannot have x on both sides if you're solving for x. You have to move x to the other side, in other words, subtract. And 2x minus x is x, so x equals 6. That's why he didn't get anywhere. He or she did not get anywhere, did not solve the problem. Because the student ended up with x on one side and x on the other. That is incorrect. Good, excellent. Solve the equation, check your solution. We've done all this. As I said, there is a lot of repetition here in 3.1. So let's see, and we'll stop whenever you want me to stop. See if this is an option. So this is number 2. Number 3, see, this is an option. Number 3, 4, 5. 5 is a good one. We have to do number 5. 6, and I'll show you why. 6, 7, yes, 8, 9, 10, 11. They all have a lot in common, but at the same time, they're different. So again, is 2 an option? We had examples like 2, but you decide. Is 2 an option?
Yes.
Okay, very good. So negative 5 quantity 3y plus 3 minus 15 equals negative 9, y plus 5 plus 3y. So since this is not new, let's take a moment and see if we can solve it. One minute. Can anyone tell us the starting point here?
Distributive.
Yes. So we have to use the distributive law here and here to remove parentheses. So can anyone dictate the next step?
Negative 15. Oh,
Yes.
Negative 15y plus.
Yes.
Or sorry, minus 15.
Yes.
Minus 15.
Good. And now we distribute negative 9.
Negative 9y minus 45.
Yes.
Plus 3y.
Good. What should we do next? Let's think before we act.
Combine like terms.
Combine like terms. Let's combine like terms. So I have negative 15y, and this is negative 30. On the other side, negative 9y plus 3y is negative 6y minus 45. Remember, we focus on the variable first. The priority is the variable. The numbers can wait. And now, I highly recommend perform the steps as I ask you to. You're going to progress in algebra much better and faster. I move this to this side, and I move this to this side in one step. When we move terms from one side to the other, the only thing that happens is we change the sign. So the negative 6y becomes positive, but we have a negative 15y positive plus a 6y. What is left? And it has to be negative. Negative 9y. Do we all agree with negative 9y?
Yes.
Now the negative 30 goes to the other side, it becomes positive. Negative 45, and I bring a positive 30, and that is negative 15. Yes, I know you feel like writing plus, 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 draw a horizontal line, la, la, la. It's acceptable. Use it. I don't mind at all. But if you really want to make progress, you will understand that this is a much better step. And it is a condensed step. I give you that. Now we have to find y, we have to divide both sides by negative 9. Since I'm dividing to negative numbers, I already changed it into positive. And remember, both are divisible by 3. So I simplify by 3, and I simplify by 3. So the answer is 5/3. If you want to write it as a mixed number, how would you write it?
1 2/3.
1 2/3. Any questions? Of course, I highly recommend go back and check. It's always the best thing to do. Okay, moving on. Any questions, please, on this problem? Don't be shy, please. Everybody was able to keep up? Any questions? Okay. Do we need to work on 3, 4, 5? 3 and 4 are identical. 3, 4. 5 is not. On 5 we have to work on. 3 or 4?
4.
Okay, so 9 minus 5/4 x equals 3/5. Here's what I would do on this problem. Yes, you can move 9 to the other side if you want first. Negative 5/4 x equals 3/5 minus 9. I will not perform any operations. I will multiply everything by the least common denominator. Don't touch anything. You separated x from the rest. Don't multiply, don't add, don't subtract, don't do anything. What is the least common denominator?
5.
Careful. The least common denominator of 4, 5, and 1.
Oh, 20.
20. So we will multiply everything by 20. This by 20 over 1, this by 20 over 1, and this by 20. No, I'm not afraid of operating with fractions, but it's easier if we eliminate them from the get-go. Okay, remember here I simplify first. Don't multiply. When I simplify by 4, I get negative 25x. Here I simplify by 5, and I get 12. And here I multiply, and I get negative 180. So in one step, I cleared all fractions, and I turned it into a very simple situation. Please remember, you have to multiply everything by 20. Don't say, I'm going to multiply just the fractions and forget about 9. You cannot do that. every term, every quantity, everything has to be multiplied by 20. When I multiply the first quantity, the first term by 20, I get negative 25x. When I multiply the second in line, then I get 12. When I multiply the last one, because this is 9/1, it's another fraction, I get negative 180. So the left-hand side is negative 25x, and the right-hand side is a negative number, 180 minus 12, and this is an 8, 1 from 7 is a 6, and I get 168. Now, I divide by a negative number. All I have to do is write 168 over 25. They may ask us, I didn't read the fine print, what do they want? Let's see what they want. Simplify your answer, give the smallest positive number by which both sides of the equation can be multiplied by. Okay, so it's a long story. Okay, so that is their recommendation as well. I applaud them this time. Okay, and then I don't know what they want, so I'm just going to write 20 first. So let's see what they want as the second step. Okay, multiply the equation by the number found in part A to clear fractions that do not solve. Okay, so they don't want us to solve. So they want us to just enter what we had, negative 25, la la la. Okay, I want to talk about this problem because we had discussions on this. 5x plus 4 divided by 8 equals x over 2. Okay, this is a very important topic. Does anyone remember the name of this expression? Because this is crucial. This is extremely important to remember. If you remember that, you have no difficulties with solving it. How is it called? I made a big deal out of it a long time ago.
What was the question again?
What is this called?
It's a equation.
Proportion. I made a big deal out of it because it's the simplest type of rational situation. This is a linear. This is not a rational equation, but it's the easiest way of thinking about it. So this product has to equal this product because it is a proportion. Remember, a proportion is one fraction, only one, the equal symbol, and one fraction on the other side. Nothing else. If I add here something or subtract something here, that's not a proportion. This is a proportion. So we cross multiply. 2 times 5x plus 2 times 4 equals 8 times x. And in one step, very simple step, very convenient step, look what happened. From whatever difficult situation into a very simple one. Okay? So now, I prefer always keeping the variable on the left. It doesn't matter. It really doesn't matter. Instead of doing this and then this, I'm just going to move this time just 10 to the other side. So I have 8 equals negative 2x. And then I divide and I get negative 4. So whenever I see a proportion, I change it into a product. Only a proportion allows us to do this. I don't know if you remember, you're way too young to remember, there was a baseball player by the name of Yogi Berra. And I remember one thing he said. I never watched him play. I love baseball, but I never watched him play. He used to say, when you come to a fork, you take it. I don't know if you've ever heard him say that. When you come to a fork, you take it. So when you come to a proportion, you take it. How do you take it? Cross multiplying. Okay? Every time you see a proportion, you say that's easy. And just attack it immediately. Okay? Good. So that's what it is. Let's see, next. Okay, what will you do here? And if you say yes, we just solved one like that. What will you do here first?
Portion.
This is not a proportion.
Oh.
Multiply both sides by the least common denominator, which is to eliminate fractions, which is
15.
15. What will you do now? This is still not a proportion. You cannot take it. You will multiply both sides by,
16.
okay,
Including the 2.
yes, of course. What about here? You will multiply both sides. They're all the same. You're multiplying both sides by, by,
36.
it's the product of the two, it's 72.
Oh yeah, 72.
Good. What about here? Do we need to work on this problem? Let's work on this problem. Negative 7/5 x plus 15 divided by 2 equals 47/6 plus 3/5 x. Now remember, we said that, let me write it again. Let's say this one. Negative 7/5x is the same with negative 7x/5. Because it's x/1, when you multiply the fraction, that's what you get. 7 times x, 5 times 1, because x is x/1. It's not important now, I just wanted to re-emphasize that. Okay, we want to eliminate fractions, so let's think in terms of the least common denominator, which is, think for a moment.
What's 30?
Yeah.